Hello and welcome to Unstress Health. My name is Dr. Ron Ehrlich. Well, today, the 20th of May 2025, is International Alzheimer's Day, and to celebrate that, we are focusing on Alzheimer's prevention is the cure. You are the masters of your brain's future health. Learn how to dementia-proof your diet and lifestyle. That is the book published by today's guest, Patrick Holford, CEO of Food for the Brain. Now, Patrick has written, I've lost count, it's certainly over 20 or 30 books. I'd have to check the exact number, but they are books on health and nutrition. So join us as we explore this vital connection between nutrition and brain health and discover strategies for cognitive well-being. I hope you enjoy this conversation I had with Patrick Holford. Welcome to the show, Patrick.
Great to be back.
Yes, back. I love getting people back, and particularly you, to fill us in on your new book, Prevention is the Cure. You are the master of your brain's future health. I mean, my goodness, there's something in the title that gives it away. But can you walk us through the sort of compelling evidence that supports this shift in the paradigm from treatment to prevention, and also, why has it been so hard for mainstream medicine to accept this and incorporate it into policy and research?
Well, the first thing is I wrote this book because I really needed to put all the content together and dismantle the fundamental belief, which is that Alzheimer's is the buildup of amyloid plaque, a protein in the brain, and that in order to cure it, you have to dismantle that amyloid plaque. And also to make it clear that prevention is, for most people, and we're talking about 99% of people, is entirely possible. And I was very pleased when leading neurologist in the US, 5 times New York Times bestseller, Dr. David Perlmutter, wrote a quote on the front, which says, becoming an Alzheimer's patient is almost always a choice. This book explains why. And in fact, I was just doing a TV news program, and they said this statement could be rather offensive. And I said, look, anyone with Alzheimer's, anyone going through that terrible demise, which I guarantee we do not need to have, you may die without your hair, but not without your memories. It's not necessary. Our teachers, like Dr. Abram Hoffer, for example, Dr. Linus Pauling, they were sharp as a razor until the end. Somebody with Alzheimer's, they would want nothing more than to know that their family and friends do not need to get this. And just like diabetes and heart disease, once you got it, you go, God, I wish I had known how to not get Alzheimer's. So I wanted to present the evidence that amyloid is not Alzheimer's, which is the first chapter, and the genes are not primarily driving this. Less than 1% is in the genes, considerably less, and we can talk about that. And even predictive genes like ApoE4, which a lot of people have and are very worried about, the impact of ApoE4 can be eliminated with the right diet and lifestyle, and that's very clear. And the next point I really wanted to make is that Alzheimer's is not a sort of mysterious disease caused by one thing. It's a sort of systems breakdown. And we see this in so much health. It's total load. There isn't just one way to get dementia, Alzheimer's. It's a combination of factors. And a simple example of this is that, in the UK, we've had some really brilliant, bright news reporters, who have a very active mind, which is one part of it, and yet they get dementia. So it's not just about using your mind. We know that the structure of the brain, and omega-3 particularly, and B vitamins, which are required to get that omega-3 into the brain, that affects the structure. We know the function of neurons depends on things like an appropriate glucose supply. So the weird thing, and we can go into that, is that too much sugar actually leads to sugar starvation in the brain. So a fuel supply problem. And by the way, whenever you make energy, you make oxidants. So smoking, air pollution, they are risk factors. So it's a combination of something going wrong in the structure of the brain, the function of the brain, and the utilization. In other words, it's a systems-based total breakdown, as most diseases are. But that model does not work well if you want to have a single blockbuster drug or nutrient that everybody takes. So those were the points that, number one, it's largely preventable. Number two, it isn't purely a function of this amyloid protein. Number three, genes play a very, very small part. And number four, it's systems-based, things that we can change and therefore not develop cognitive decline as we get older.
I mean, gee, when we talk about a systems-based approach versus a reductionist-based approach, we may as well be talking about an integrative approach versus an allopathic approach or the traditional medical approach, because so much of modern medicine is reductionist, is it not? So much of modern medicine is looking for that blockbuster drug.
Well, it's true. And strangely, and we owe this to Professor Gerald Raven back in the late 80s, maybe 90s, who developed the concept of metabolic syndrome. And basically what was happening there was a lot of people getting heart disease and getting diabetes and being chronically overweight had the same pattern of results in blood tests. They had high cholesterol, or more importantly, low HDL cholesterol, high blood fats, triglycerides, sugar problems measured one way or another, very often by the glycosylated hemoglobin, HbA1c. Some say that raised homocysteine, which we should go into because it's so important, is part of that. And he called this metabolic syndrome. And that is a systems-based approach. And that's probably, I think, the only kind of systems-based lens, that has been applied. And I was looking at a study of almost 2 million people that came out 2 weeks ago. And it showed that people with metabolic syndrome have I think it was a 22% increased, risk of dementia. So, yeah, we don't think, in a systems-based way, and we need to.
I mean, the other problem, of course, is that the medical practitioners at the coalface are really, they are practicing what they believe is evidence-based medicine. And a theme of this program is that it's difficult sometimes to tell the difference between evidence-based medicine and evidence-based marketing. And this is part of the problem we find ourselves in modern medicine, is it not?
Well, yeah, and I think in this generation of AI, it gets really, really interesting. You see, so the what's called evidence-based medicine, and it's very interesting because the sort of evidence-based medicine concept as it is now is don't go into the logic, don't go into even necessarily mechanism, just show me a randomized controlled placebo trial where a particular treatment had a sort of measured effect, right? So we don't need a story. We just need the trial that shows that substance X, cures the disease. And then the idea is you get lots of those randomized controlled trials together, and you have a meta-analysis and a systematic review. And that's, what should drive and change policy. So let me sort of break this down a little bit. The last two trials, donanemab and lecanemab, now these are the anti-amyloid injections. These were very big trials on about 1,800 people. And I am informed that the cost of these trials, which are trials over, I think it was 18 months, we're in the region of $250 million. right?
Yep.
So now in my book, I say over 100 million because I don't exactly know. So instantly you think, how do you get $250 million? And the answer is there is only one industry that could possibly do that. That is pharma. And the only reason anybody would spend $250 million is that they think they can get, billions back. So the drug maker spends a lot of money on what seems to be a well-designed trial. Okay, so now you go meta-analysis, right? Let's get a few of those together. Okay, so now you're up into the billions, and here's the irony: the latest UK meta-analysis systematic review doesn't even mention homocysteine and B vitamins. I'll just use that as an example. Diabetes accounts for 2% apparently of Alzheimer's risk. Now, in the US, the similar meta-analysis has homocysteine, which is a toxic amino acid, a consequence of lack of B vitamins. In there is 22% of the risk. So we've gone from 0% over there to 22% over here. And then the biggest, and I think actually still the best, in China, which was a meta-analysis and systematic review of 396 studies, something like 160 randomized controlled trials, has homocysteine-lowering B vitamins as the most promising treatment. So now you've got evidence-based medicine at its apparent best, randomized controlled trials in meta-analysis, completely disagreeing with each other, and one major effect being completely excluded and another included. And it took me back to, I was actually studying Elon Musk's obsession with driverless cars. And what happened was he was spending hundreds of millions, had genius programmers trying to invent all the rules and regulations and conditions, and and it failed. And then someone said, you don't need to do it. You're doing it the wrong way. What you need is a lot of data, and AI will do it for you. And when they had over 1.3 million drivers' data from all the Teslas and prioritized 5-star Uber drivers, they actually have now in California highly effective, my kids have been using them, driverless cars. And they say they're really, really good drivers. So that made me realize, and that's been our project here at the charity foodforthebrain.org. Yep. And this Alzheimer's Prevention Day, 20th of May, we go global in China, Japan, Brazil, America, US, Australia, and all of Europe and German and Polish, is to collect a lot of data, because basically when you go on the test, either the full test at foodforthebrain.org, or if you wish to have a little sort of bite-sized 3-minute test at alzheimersprevention.info, which is the website for the Alzheimer's Prevention Day, then you test your cognitive function. So now we have a measure of how you actually are, and that's a validated test. You then fill in a diet and lifestyle questionnaire, and which works out your risk. If you're doing everything wrong, you have a high risk. If you're doing everything right, you have a low risk, and it shows you what to do about it. And we will then invite you back in 6 months and every 6 months to repeat this. So we're collecting data. And now, brilliantly, we've developed a single pinprick blood test, a kit that you can get, and it will measure 5 critical biomarkers, so to speak. All this data is pouring into a research database. We're getting close to 500,000 data now, 500,000. So in China, the group we're working with wished to test 18 million. And just like those driverless cars, we're on the hunt for those people whose cognitive function doesn't decrease with age, is projected to hit nowhere near the sort of cognitive dysfunction stage. And then we simply ask the question, what do they do? So I have a feeling in the next 10 years, this sort of edifice of evidence-based medicine, which is only affordable by major players, And all those wonderful professors who do the systematic reviews and meta-analyses are all on the payroll one way or another. And by the way, the crazy thing, of course, is that their advice should then inform governments, but not a lot gets through anyway. Will start to break down, and we will enter a new age, a function of big data and AI, where we can and will go directly to people in their millions and billions, and people can then be more in charge of their health. So I think we are in a paradigm shift in the way that medicine and science is about to be done.
And I think it's interesting to anybody that's used AI at all that the key is prompts, to put in the correct prompts. And if your prompt is, as I would say, a vast majority of medical practitioners' prompts are, what is the pharmaceutical product that I can prescribe to deal with the problem sitting before me? That is their prompt, and they go ahead and service a $1.5 trillion industry. But if you are using AI and the prompt is, what are some of the prevention, what are some of the biomarkers, what are some of the things that I can do, I think we're going to find that data comes up very differently. You've mentioned a couple of times biomarkers, and I want to come into this, and you've also mentioned food for the brain and the cognitive function tests that 500,000 people almost have done. And I want to come back to that as well, because I think it's one of the great initiatives in the world of healthcare today. So congratulations on that. But let's talk about biomarkers. Let's just break this down a little bit, because they are important, obviously, and people may not be that familiar with them. So let's talk about the biomarkers. You mentioned homocysteine. Let's go through them a little bit.
And just before that, I think what has to be acknowledged and understood by reasonably intelligent people is the two-step dance. Now, the two-step dance is most well illustrated by cholesterol and statins, which have made in the trillions of dollars. Yes. So the idea, and I could use myself as an example. So I'm super healthy. Every measure that relates to heart disease, triglycerides, for example, blood pressure, for example, everything's perfect. I'm 67. I'm a paraglider pilot. I'm fit. I'm healthy. I feel fantastic. My blood pressure is perfect. Everything is perfect. My cholesterol is over the magic number of 5.2 in the UK system. And my doctor says you need to be on statins for the rest of your life. And
I'm sure that's a message that a lot of people have heard.
Yeah.
Patrick.
And I said, how on earth do you work that out? And I said, what's the NNT? NNT means numbers needed to treat for a benefit. For somebody my age with he said, I can't possibly be expected to know the NNT for all the drugs I prescribe. Well, I said, that is your job, because it's pretty much infinity. And he said, oh yeah, the system gives us a calculator. It's the Q risk, and I put in your age and I put in your cholesterol, and it says prescribe statins. So this is what we call the two-step dance. You take some measure and you convince everyone it's important, and you tell them you've kind of got a disease, heart disease in waiting. There's no evidence of it, but it's in waiting. So that's really what right now in the dementia Alzheimer's world, millions are being put forward to find the marker, the blood test. And here's a real irony, because and the Bill Gates Foundation have put up a lot of money in the UK for this whole big project going on this to find the marker. And you're thinking, okay, so we'll have this test. We talk, you've got dementia in waiting, so I feel fine. So at the moment, there's a great big bid, which we're part of, to then test the cognitive function, right? So, of course, if I said to you, do you want a blood test to find out how fit you are? You go, wouldn't I have a fitness test? So if you want to know your cognitive function, which, by the way, because we've done 400,000 of them, is decreasing steadily from the age of 18. So in other words, it's an exquisite marker of measure of cognitive function. I mean, is decreasing consistently from the age of 18. They now want a really good cognitive function test, and they're considering ours, in order to validate the marker of the blood test. You see the irony of this? Why not just have the cognitive function test? And the point about any marker is, well, what can you do about it? So the idea, well, oh, you've got cholesterol, you take statins, so there needs to be a consequence. And that's what the pharma industry would love. Blood test, drug, blood test, drug. So we look at this very differently in a systems-based way. And what that means is that biologically, and it's not just our biology, using your mind is important, for example, as well, and sleep is important, and so on, is that there are 4 fundamental breakdowns in our biology. I call them the 4 horsemen of the mental health apocalypse. And they are just as applicable for things like autism as they are for Alzheimer's. And one of them is the brain fats, because your brain is, when you take the water out, 60% fat. And 2 of the most fundamental fats, well, one is omega-3, and the other is actually it is a fat, but it's really a hormone, vitamin D. We don't fully know how vitamin D works, but we do know more vitamin D, less dementia. So those are 2 things we want to measure. Then what happens is the ability to put omega-3 into the neuronal membrane, that's like the talking skin of the brain cell, is done by a process called methylation dependent on B vitamins. And if you're not doing methylation, your blood level of this toxic amino acid called homocysteine goes up. So we want to measure that. And then, of course, we want to measure where you're at in relation to sugar. And we can go closely into why. And the best single measure for that, it's not the only one, but it's probably the best, is called HbA1c, or glycosylated hemoglobin. And then also we want to know, is your brain aging through oxidation? So oxidation, antioxidants, oxidants, very important. And we've developed a world first of measuring the most important and highly unstable antioxidant within cells called glutathione, which then gets oxidized. So it becomes, if you like, spent glutathione. And we measure the ratio between the fully loaded glutathione in your blood and the spent glutathione. It's a bit like the water in the fire truck. So, turning into steam. And we measure that as well. And the point is that every single one of these measures, omega-3, vitamin D, HbA1c for the blood sugar, homocysteine for the B vitamins, and glutathione, tell you exactly what to do. So, eating more fruit and veg and vitamin C will lower the glutathione, and having more oily fish, will lower or improve the omega-3, and getting some sunlight, not always being, in full sun block, for example, will make more vitamin D as well as oily fish. And having more, greens will give you folate, and having some B12 from eggs and fish and meat and animal foods and supplementing I'd recommend as well. And, having less sugar, less carbs will lower the HbA1c. So you've immediately got things that you can know what to do. And I would propose, of course, we don't know this yet, but this is the beauty of, big data, so to speak. I would propose that if you've got your omega-3 in the right place, and your vitamin D, and your HbA1c, and your homocysteine, and your glutathione, I would suggest that it is impossible to get Alzheimer's. But we will find out. And also, a lot of these tests, by the way, I should explain this, are red blood cell tests. So omega-3 measures the percentage of the fats within red blood cells that are omega-3, EPA, and DHA. Those are the important ones. And the point about red blood cells is that they live for about 3 months. So every 3 months, you're replacing them. So what it means is that the test is giving you an average, so to speak, for your last 3 months. So we would say make some changes and retest in 3 months. So it's not going to be affected by the fact that you had salmon for dinner last night. And that, that's really nice. So they're robust, measures rather than things that, like if I measured your glucose, it could be high, it could be low, it depends entirely on what you've just done. So that's why. And so the beauty of it, and this is, it's not AI, but it's not quite nanotechnology yet. We hope we could get there. But we have bits of equipment which can measure down to, well, for some for some substances, parts per trillion, but for most, parts per billion. So you get a kit, you have a pinprick, you prick your finger once, and a few drops of blood, and it's stabilized instantly, goes back to our central lab, who then measure highly accurately all of these. So that's cool, a home test kit that you can do yourself that measures these things, so it is objective, and then as a consequence of that, advises you what to do. So no more guesswork. Don't just get, I think I eat fish or whatever. Find out, because we are all so different.
Do you have to get that test back to the laboratory in a 24, 48 hour period, or does it withstand
about 12 weeks?
12 weeks. Wow. Okay. That is stable.
So exactly. And
even Australian Post would get that through.
The point is we have a centre in Australia. So the kit comes to you from the centre in Australia, goes back to that centre, who then DHLs it straight to the lab. So it's going to get to the lab anyway within 2 or 3 weeks. And when that blood drop hits the card, it is then stabilized, and then goes inside a sealed aluminium envelope with a bit of moisture protection. So it's very stable. And you'll know things like glutathione, any of these antioxidants, they oxidize very, very rapidly. And so we kind of sussed it. I mean, I'd love a future. I was just over at our lab, which is in Poland. I'd love a future where you could do it all on one drop of blood, and sort of nanotechnology. And I think they just invested in a bit of equipment which is costing them over $1 million Australian dollars. So we're trying to get smaller and smaller and smaller. And funny enough, what happened is we have a few people. When you're doing 5 blood tests, theoretically you would need 5 drops of blood, but just in case someone doesn't do it right, you need a couple more. And that is doable. I just did all my grandkids, but for some people it's difficult. Maybe they don't bleed very well, or they don't follow the instructions, or whatever. So I was just test driving a bit of kit, which I think we'll use, where you slap this thing on your arm, can't feel a thing, and just wait a couple of minutes, and a little container fills up with your blood. So it's a painless way to extract blood, and then you just drop it onto the card and then leave it a few minutes. It dries in the envelope and off. So now we have a painless method to do it absolutely 100%. But it's about, it's going to add on, I don't know, 30, maybe even 40.
What is the cost? What is the cost of that pinprick test?
Well, the kit is around, £200, whatever that is. Is that is that 400 Australian dollars? I'm not sure. $2.
Right. Yeah. Yes. Sadly, it is
something like that.
Yes, it's almost 2 to 1 now. I'm just about to go over to England myself. I'm lamenting at that exchange rate. Hi, Dr. Ron here, and I want to invite you to join our Unstress Health community. Now, like this podcast, it's independent of industry and focuses on taking a holistic approach to human health and to the health of the planet. The two are inseparable. There are so many resources available with membership, including regular live Q&As on specific topics with special guests, including many with our amazing Unstress Health Advisory Panel. Now, we've done hundreds of podcasts, all worth listening to, with some amazing experts on a wide range of topics. Many are world leaders. But with membership, we have our Unstress Lab podcast series, where we take the best of several guests and carefully curate specific topics for episodes which are jam-packed full of valuable insights. So join the Unstress Health community. If you're watching this on our YouTube channel, click on the link below, or just visit unstresshealth.com to see what's on offer and join now. I look forward to connecting with you. It's interesting to hear so much emphasis put on omega-3. And typically, omega-3 and omega-6 are kind of played off one another. But omega-6, I mean, putting aside processed seed oils,
Yeah.
omega-6 still has an important role to play in the body.
Well, you're totally right. And if you look at neuronal membranes, if you look at the brain of any animal, it has to have two fats. The predominant one is omega-3 DHA, which is a marine food fat. And the other one is arachidonic acid, which is a plant-based omega-6 fat. It's not only in plants, it's also in milk, it's in meat, like milk from cows that eat grass, but they had to get it from plants. And I think it's actually very hard to get omega-3 and not get omega-6. That's the point. So omega-6 is more abundant and omega-3 is less abundant. So hence the biggest deficiency, is omega-3, but you're absolutely right. And, eating any plant seeds or seed oils. I mean, olive oil will give you some omega-6 and obviously sunflower, sesame seeds. I love tahini, for example, which is sesame seed spread. Yep. And something that really sort of puts this into context, and it also is a very nice example in a way of the concept of genes and environment, is that Darwin said there are two forces driving evolution. One is natural selection and the other is conditions of existence. Now, I'll give you, but he said the conditions of existence is more important. So I was just in London doing a TV show 2 days ago, and in the garden of the place where I stay, I saw a fox. Now, you do not see, there are loads of foxes in London, but there are no badgers. So when the conditions of existence change, urbanization, lousy for badgers, good for foxes, that's natural selection. And Darwin said it's the conditions of existence that are more important and precede this natural selection, which in a sense is kind of the genetics. And everyone from Hitler, to the aristocracy, they loved the idea of natural selection, that we've got blue blood, we are special in some way, or, we are white and better than black, or, Hitler with the Aryan race and so on. So all that kind of eugenics was sort of, it was about genes. Then when we discovered genes, everyone goes batshit about genes. And they still are. I mean, it's extraordinary if you look in the world of cancer, the trillions that have been spent pursuing the idea that your genes are causing, the cancer. So that's, if you like, natural selection. So what happens is a whole lot of dinosaurs, it's only reptilians. In other words, they lay eggs. There are only giant plants with inedible seeds, vast, seeds of vast palms, etc., etc. And then along comes a meteor, we're pretty certain now, wipes them out. And suddenly you're into this new explosion, the Cambrian explosion, where there are now flowering plants rich in omega-6 with edible seeds. So omega-6 kind of joins the food supply, so to speak. And before long, and we don't know exactly how this occurs, we've moved away from reptiles, like chickens lay eggs, and we've moved into mammalian development. So that egg, rather than being laid, is actually hanging around, in the womb for a period of time. We don't quite know how that happened, but we think omega-6 had a lot to do with it because it's sticky. So you can imagine the egg sort of sticks and eventually, moves to the point where the egg stays. And now I remember asking Professor Michael Crawford, who is the man who discovered omega-3 in the brain, the ocean is full of omega-3 DHA. Why are fish so stupid? And he said, well, think about it, Patrick. A mother cod can lay 1 million eggs. So that is the mother's nutrition of one day divided by 1 million. And that is all the little codlet has to build its brain. While we, on the other hand, we have 9 months of gestation. Omega-6 builds blood supply. A fetus has a beating heart 2 weeks after conception. So you've got 9 months of circulation of nutrients into the fetus, 9 months of nutrition. And you need that, to build the brain. So omega-6 was almost certainly involved in shifting to mammalian development. And you can't have a big brain if you don't have a big heart. So we predicted a long time ago that the two organs that would break down in our awful, modern day diet would be the heart and the brain. A phenomenon, and Alzheimer's is really illustrating that point. So a lovely example of conditions of existence driving evolution, and the importance of omega-6 as well.
I'm always intrigued by the focus on seafood, because I then start to feel really sorry for all those people that have evolved away from the coast, and how on earth did they ever survive? What would be your response to that, where people have, is it only coastal communities that have done well through evolution? This is a much bigger question, of course, but
it's not seafood, it's marine food and the marine food web. So first of all, if you think about it, and by the way, what's relevant here is that 6.5 million years ago, our ancestors split from bonobos, gorillas, and chimpanzees, whose brain size has not changed at all. Basically, it's under 400 grams. And gradually, over that 6.5 million years, brain size gets bigger and bigger and bigger and bigger, and hits a peak of just under 1,700 grams, 1.7 kilos. This is all done on skull size, so skulls get bigger, in effect.
Yep.
And today our brain size is 1.33 kilos. So we've lost 20% of brain size in the last 20,000 years, and we gained this massive increase in brain size steadily. So how? The first thing is, of course, we had to evolve by water. If you're not near water, you can't survive. Water is so important. So, of course, rivers, streams, estuaries, wetlands, swamplands, and coasts had to be part. And the migratory routes out of Africa, are always along water, because that's what you need. We didn't have plumbing, so we didn't have bowls, we needed water. And wherever there is water, there is marine life. So it's not just coastal. It's also in rivers, estuaries, and so on. And the next thing to realize is those beautiful coasts, that you see around Melbourne and Sydney, and in creeks and all the rest of it, which are full of those, $1 million apartments and houses and all the rest of it. Not so long ago, before the humans were there, they're absolutely abundant, with mussels and cockles and crabs and lobsters and fish and all the rest of it. I was recently on tour in Ireland on the southwest coast, and I asked my host, what was it like when you were growing up? They said, well, the sea was just buzzing with mackerel. You couldn't throw a line and not catch a mackerel, and normally you'd catch more than you need, and you'd be offering it to your neighbors, and there's we got plenty. So the fish supply and the marine food supply was very, very plentiful. So, and where I live in Wales, they discovered some years ago a 40,000-year-old complete skeleton. It's the oldest complete Homo sapiens skeleton in the British Isles. And they assumed it was a woman because it had all this jewelry made from shells, like a lovely necklace made out of shells. And when they did the DNA analysis, it was a man. And about a quarter of their diet was marine food. And this makes sense because, why go hunting for an animal that runs away when you can actually walk along the beach, walk along as the tides go in and out, and pick up the mussels and all the rest of it, and maybe a few fish in rock pools and so on. And we think this is how we became upright. And there's about 20 pieces of evidence for why that would occur. But the one very, very simple example of this, which actually was picked up on by Sir David Attenborough, who's just turned 100.
Yes.
And
Incredible.
Is very into everything we're talking about. He said a human baby is born with this white, waxy, waterproof stuff called vernix. He said, I have never, ever seen this in a land-based mammal. I wonder if it occurs in the sea mammals, the mammals that moved into the sea, like seals, sea lions. Dolphins were actually the last animal to fully commit to the ocean. And a marine biologist in Canada picked up on this, and sure enough, seals have identical vernix to us humans. So we think we are the waterside ape. We became upright, we developed our manual dexterity, we have our big brain because we had the right conditions of existence, both marine food and plant food. And that's such an important question. How did we become human? What is the origin of our dominance, which is purely a function of brain function? And when you understand that, you then take a look at what we're doing and you understand why our brain size is shrinking, why autism is going through the roof, why Alzheimer's is going through the roof, why neurological diseases are going through the roof, and what we need to do about it. These are the proper questions to ask.
I'm intrigued. I often am when I follow that evolutionary development from apes 6 million years ago. I think they had a brain size, they still do, of around 400 cc's, and as you observe, we peaked at 1650 or 1700 cc's, which kind of begs the question about how vegan brain health. How do we? What message do we have for vegans? Patrick?
Well, generally it's poor, and particularly for B12 and omega-3. And I wrote a book called Optimum Nutrition for Vegans, because if someone chooses to be vegan, I think a lot of meat eaters, because I've been involved in a lot of debates on this in conferences, the one thing they don't really ask and understand is that a lot of people choose to be vegan because they don't want to kill animals. And we have to respect the concept of that. And my view is, if you're willing to eat something, you should be willing to kill it. And and life there, the life of that fish becomes my life. So if I'm going to do it, I want to do it out of respect. I really hate seeing people eat meat and just sort of leave it on the side of the plate. Don't waste an animal. And I'm sure this would be true in the sort of Aborigine culture and the Native American culture. You wouldn't catch an animal and waste it. You would eat the whole thing. So a lot of people come towards veganism from that point, and we have to respect it. But there are major problems. You cannot get omega-3 DHA from any vegan food. Chia, flax, etc. will not convert readily enough to make DHA, and that's why there are no vegan, cultures in history that survive.
Yes.
So, but you can buy omega-3 DHA derived from algae, and so this is made. There is certain algae which they are cultivating in vast quantities, which will fix DHA. So there is a solution. Similarly for B12, there is a solution. But what's recently at foodforthebrain.org, we've launched a whole project similar to the Alzheimer's prevention project called Cognition for Smart Kids. So we are now able to test children in every respect, and their parents, and questionnaires and online tests and so on. And what I started to dig into that, and I'll give you a little example of this. Vitamin B12, the serum B12, which is the blood test that a doctor will use, not the best test, but it's what's available. What we know is below 500 units or picogram per mil, you get brain shrinkage. So the optimal level is above 500. And that is what's used in quite a few countries. Like in Japan, if you're below 500, you are considered to be deficient. And in the UK, the reference range is 180. So there are a lot of countries where the reference range is wrong. And in the EU, a third of children are below 220.
Because what they're often referencing is what is the population normal, which may well be true.
Yeah, exactly.
Not optimal, just what is normal.
Exactly. So what we know now from major studies is that there's a phenomenally large percentage of kids and adults who are deficient, in other words, in the brain shrinking zone, in other words, definitely not in the neurodevelopmentally optimal zone, for vitamin B12 and also for folate, the B vitamin from foliage and greens. So you could kind of imagine that that is the case. And then there's something else on top of this, because I live in a farm and we grow our own food, but we're actually running experiments. So we are organic certified, but we're way beyond that. And so the first thing we did was to analyze the nutrient content of the soil, and we've rebalanced the soil, et cetera, et cetera. But our experiments are how do you maximize nutrient content in food? But I'm working with the Bionutrient Research Institute, who have tested thousands of plants and foods and meats and so on. They find a 40-fold variation in the nutrient content of organic food. Bought in a farm, bought in a shop, biodynamic, zero dig, organic, honestly, a 40-fold variation.
Wow.
So, number one, are kids eating greens, which would give folate? Are they eating fish or eggs, which would give some B12? That's probably a little bit more stable. The point is the animal can't exist if it doesn't produce B12, so it's got to be there. But things like, zinc, vitamin A, the plants don't. You can get a carrot to grow, but with very little vitamin A. So there's no guarantee that carrot that you eat thinking you're getting vitamin A is giving you vitamin A is 40-fold variation in vitamin A in carrots. And the farmer, in a sense, doesn't care if his carrots have got vitamin A. He just wants to grow a lot of carrots very fast and sell them. That's how you make money out of farming. You don't get paid more if your carrot is in vitamin A. So I think we're more malnourished than we have any idea. And then the other thing, of course, is we're more intoxicated. I mean, if you think only now are we getting to the point of realizing that most people have a credit card's worth of plastic in their brain.
Yes. Which Patrick, I mean, one of those areas where we are exposed to that is the sea.
Yes.
Which kind of throws the whole fish story into a little bit of a question from the conditions of existence, because the conditions of existence for fish ain't great.
No, you're right. And it means we have so got to prioritize the oceans in every way that we can, and we have so got to stop all this plastic pollution. And I'm only a little bit encouraged that when you do analyze fish, you find the plastic residues mainly in the organs of elimination, the liver, the kidneys, and the gut, and not in the flesh.
Interesting.
Right? Which is, so if you buy a mackerel, you don't really find plastic in the flesh. And we don't quite know what the effect of all this plastic is going to be. But the other thing that is relevant, and there's a lovely study on this, is very, very clear, is that this was a study which looked at omega-3 in fish, thousands and thousands of fish analyzed, and people's consumption of it. And fishes also contain selenium. The bigger the fish, the more selenium, which is good, and mercury, which is bad. The bigger the fish, the more the mercury and cadmium. And the study by Sasaski, S-A-S-A-S-K-I, very, very good study. It shows a massive benefit for mental health, the more omega-3, a small benefit, the more selenium from the seafood, and a very small negative from mercury or cadmium. So in effect, probably you could say that the benefit is 50 times greater than the detriment. And also understand that the bigger the fish, the more it accumulates mercury, cadmium, and selenium. So you could say sort of salmon or smaller, and you might get a little bit worried with big bluefin tuna. And especially when you're buying the tin stuff, because they've squeezed the oil out to sell it to the tunins. I actually, when we buy our omega-3, we think, where's it from? We think salmon.
Yeah.
I just learned it's mainly from anchovies, and mainly from the massive anchovy runs around South America. Interestingly.
Oh, that's interesting.
Because we
That's
say smash
reassuring.
it. Salmon, mackerel, anchovies, sardines, herrings
Mm-hmm.
are the fish that really provide you with these nutrients. So
And when we are talking about salmon, I mean, in Australia, farmed salmon is the norm,
yeah,
and that is a very different beast, literally, to the ocean caught salmon. I mean, anybody that's tried the two will know the huge difference.
it's true. And Professor Michael Crawford, who discovered omega-3 in the brain, and he's 94, and he's just published a paper solving how we see, because no one's been able to explain how we see so speedily and accurately and in color.
Hmm.
And his quantum physics and biochemistry, 94, solving problems.
Yeah.
He is a big advocate of recreating the marine food web. So we were gearing up to launch in Japan and China later last year. And in Japan, they've taken considerable areas between islands, stopped all trawling, planted sea grasses and seaweeds, just as you would plant grass in a field for a cow, created artificial reef structures that favor the keystone species of fish and they want to invite back, and regenerated the marine food web to the extent that they've probably increased their marine food supply by tenfold. Not by sticking an animal into a tank, overcrowding and feeding and then having to feed antibiotics because they get sick, but simply by changing the conditions of existence,
Yeah.
which is what we, orthomolecular or functional medicine or whatever we wish to call ourselves, are doing. We're just saying, here I've got a person in front of me who's not very well, and I want to change their conditions of existence, improve their diet, improve their, have the right supplements and, reduce toxins, change the conditions of existence, and sit back and wait. The human body and brain responds so incredibly rapidly. All we have to do is give it the right, conditions. And funny enough, in the plants, what we found, this only measure that actually predicts the nutrient density of a plant is a measure of the respiration of the soil. You can measure if the soil is breathing, and it's only breathing if it has a good microbiome. You need a bit more fungi than bacteria. And it's only going to have a healthy soil life microbiome if it's got the right nutrients in the soil in the first place. And that is the only thing that measures, predicts the nutrient density. So we're just the same. We need the right basic nutrients in order to have a healthy body and a healthy microbiome. And consequently, we end up healthy ourselves.
Well, that conditions of existence is a topic that we've championed on this program many times in terms of animal welfare, because if the conditions of existence are on the land living as they are meant to live, then we have a very different beast to what is grown in a pen. But I want to finish on a positive note because food for the brain and the power of citizen science is something that I just think is a wonderful achievement. Tell us a little bit, how does Food for the Brain initiative work and what role can listeners play in the citizen science movement?
Well, first of all, on a very practical level, and this is all free, if you go to foodforthebrain.org and you click on the button that says take the test, you will then need to spend about 10 minutes doing a cognitive function test, which is not a questionnaire. It's interactive. It will ask you to identify, it's a test. So kick the cat out, turn the phone off, sit down, concentrate. Then there's a questionnaire which asks you about your diet and lifestyle and what you eat and what you do and how much you exercise and other such things. And from that questionnaire, it will work out your percentage risk in the future of cognitive problems and will show you what's driving that risk. We actually fund the charity through a program called Cognition, which you can join, which is about $100 a year, where you then pick the area you want to work on, and you'll then get emails and text reminders and Zoom groups to join and things to watch and things to listen to. Basically, everything designed to change that bit of behavior and support you. And once you've done that, you can see your score improve and you can move on to the next. So it's kind of like a game that you can play over the next 6 months or a year to get yourself in a good place. And that's the process. But the actual test that works out where you're at and what you need to do about it is free. And that is at foodforthebrain.org. And that's where I'd prefer you to go because you're doing the full thing. But we do also have, to mark Alzheimer's Prevention Day on May the 20th this year, a simplified version of just the questionnaire. And that website is alzheimersprevention.info, which is like a 3-minute test, so less questions. That it's designed for people who won't spend 20 minutes doing the full thing, but I'm sure that you will. And, for people who may be very, very new to this, as a sort of little feeder, a little teaser, but all this data, and of course you can choose to order the blood test kit and have that as well, which is anonymous. So you will get your results and you will be told what to do. But if you were to contact us and say, why are my results like this or whatever, well, we can't actually get your results. You can share them with us, but it's anonymous. So anonymized at that point, that data goes into the research database. You have now become a citizen scientist because you are spending the time to do these tests, hopefully every 6 months. And we are collecting that data. And then we are able to see on a big scale who does well and who doesn't. And then in the world of randomized placebo-controlled trials, they say, well, where's the placebo group? Where's the control group? And we say, well, look, we're getting data on millions of people. We don't need a control group because there are some who don't stop smoking and there are some who don't start exercising. There are some who do supplement omega-3 and some who don't supplement omega-3. And by the way, the context of this also is that these, in studies, they call it confounding variables. They have two groups, and they say, let's not include diabetics because that's complexities and who is or isn't taking drugs or doing exercise or smoking. What are the confounding variables? And we're going to mathematically try and control for all these interactions and variables. And in our world, we say, stop it. Reality is multifactorial. We're all doing different things. And with AI and digital technology, we can actually see the patterns. We can see the impacts of things. So even if you do it, the test, and make no changes at all, you are a citizen scientist. Come back and do it again. We're going to learn so much in the next few years. And what's lovely about it is that researchers at universities who wish to study this or that, and we've already got a number of who are doing this, can then access this data to start to look closely at particular things. And we hope that very soon we will be the largest database for dementia research in the world, not funded by any vested interest, because all this is 100% charitable and always will be. Largely funded outrageously by lovely people like you who decide to become a friend of Food for the Brain and chip in $100. Mm-hmm. And, if a lot of people do it, we can grow faster. And if less people do it, we grow slower. But we're growing 14-fold in the last 2.5 years. And it's global. We've just translated the Alzheimer's Prevention.info site. You will see all the flags above. You can read it in Arabic and French and German and, Japanese and Chinese. So we've gone global. And we hope by the end of this year to have translated everything, including the cognitive function test, into enough languages that 60% of the world's population can do this. And there's a lot of really good free information. So it's not, you don't have to, be rich to do this. Anyone can do it. And that's our goal. A digital united world, changing behavior to millions, if not billions, thanks to every one of us just taking a little bit of time to find out what we need to do ourselves to keep our brains healthy forever.
Well, Patrick, thank you. I mean, thank you for the initiative. I believe it is one of the great global health initiatives, and I'm very proud to have supported it and to continue to support it. And with your book, Alzheimer's Prevention is the Cure, which is out in Australia, we'll have links to all of these in the show notes. Thank you so much for joining us. Thank you so much for your sharing your knowledge and wisdom with us.
And thank you for spreading the word across Australia. Thanks.
Well, if you haven't already done the cognitive function test, I would encourage you to do it. I believe Food for the Brain is one of global health's, the most exciting global health initiative. And with over almost 500,000 people already having done this cognitive function test, which consists of a digital version of the dementia test you would do if you were being tested for that, together with lifestyle questions that look at your conditions for existence. We'll have links to that in the show notes. I hope this finds you well. Until next time, this is Dr. Ron Ehrlich. Be well. Feeling stressed, overwhelmed? It's time to unstress your life. Join the Unstress Health community and transform stress into strength. Build mental fitness. From self-sabotage to self-mastery. And together, let's not just survive, but thrive. Expert-led courses, curated podcasts, like-minded community and support, and much more. Visit unstresshealth.com today. This podcast provides general information and discussion about medicine, health, and related subjects. The content is not intended and should not be construed as medical advice or as a substitute for care by a qualified medical practitioner. If you or any other person has a medical concern, he or she should consult with an appropriately qualified medical practitioner. Guests who speak in this podcast express their own opinions, experiences, and conclusions.